Hey guys, in the last video, we kind of got cut off, only able to record 30 minutes at a time, so we kind of missed out on question 19 and 20 that had also been requested, and so now I'm going to go back and do those two questions on this video. Okay, question number 19. Now 19, the way the question is asked seems more complicated than it actually is. This pretty much just goes back to our basic rules for antiderivatives and what we can and cannot do when we're solving the antiderivative. So if I look at choice one is pretty much telling us that if I were to take an antiderivative from a to b of a function times another function, so let's say I just have x squared times y. Alright, this is trying to tell me that I could split that up into x squared dx times the antiderivative from a to b of y dx. Alright, so that I could take the antiderivative of each piece and then multiply the result together. That is not true. That is not something that we have ever done in this class. Alright, it is not something that could be done at all. Alright, so that rule is not a true statement, so one is out. Choice 2 says that if I take the antiderivative from a to b of a polynomial function, so x squared plus 3x dx, can I split that up to the antiderivative of x squared dx plus the antiderivative of 3x dx? And the answer to the question, can I do this, is absolutely. This is what we do every single time. We take the antiderivative of each piece individually and then continue to write it as a polynomial. So choice 2 is absolutely a correct step that can be done during our antiderivative process. And finally, choice 3 is saying, okay, if I'm taking the square root of a function, can I really just take the antiderivative of the function as a whole and then square root the result later? Absolutely not. Anytime we've seen a square root, what we've done instead, bring that down here, is, right, if we see a radical, we rewrite this as a fractional exponent and then deal with the power rule. Okay, you are not allowed to do choice 3 either. So choice 2 is the only one that is a correct statement here in regards to integral rules. Okay, so again, even though the question seemed a little odd, if you then look at the different statements and really see what it's trying to ask, what it's talking about, you can really see that choice 2 is the only one that's an actual step that can be done, a real process in our antiderivative rules. All right, guys, so question number 20, final one that I was asked to go over in the multiple choice section. This is another example of that fundamental theorem of calculus, part 2. I'm given that f of x is equal to an antiderivative statement, but then I'm asked to evaluate f prime of x. So if I want to find f prime of x, that means I'm taking the derivative of the antiderivative. And when we had gone through this process, we did the long way a couple of times, and then we came up with some shortcut rules. But really, if you're taking the derivative of the antiderivative, all you're doing here is you're replacing that t value with this x value. So my f of x function, my f prime of x function, that's what I'm looking to find here, f prime of x, what I get after I take the derivative of the antiderivative, is going to be the square root of x cubed plus 1. Now, just as a side note, because again, I know a lot of you guys don't have your notebooks with you, if this had been like 2x, right, then I would have 2x cubed, and I would have had to multiply by the derivative of that b value, 2. So I'd have a 2 out in front also. Okay, there was also that if, let's say, the 0 was up here and the x value had been down here, right, we would have to interchange those two, and that would bring a negative out in front of our function because we were flipping the direction of the those a and b values. Okay, so there were kind of 3 basic rules there. However, this one, which is nice, we're just going with that first statement and just replacing with x. So just cleaning up my work here a little bit. All right, I'm given my derivative statements, so now I'm going to just evaluate f prime of 2. So if I plug in, I've got 2 cubed plus 1. 2 cubed is 8 plus 1. All right, so we're looking for the square root of 9, and the square root of 9 is 3. Somebody asked specifically, why can't it be negative 3? Right, some of you guys are recognizing that, okay, yeah, sometimes when we take the square root of something, we get a positive and a negative. Well, here's the thing. If the square root is already in the problem, that means you're only going to end up with the positive value. The time that you end up with both positive and negative is if I had an equation, and that equation said my x squared value is equal to 9. And then I physically have to square root both sides. Because now it's that the x value could be, I could plug in positive 3 square it and get 9, or I could plug in negative 3 and square it and get 9. However, in this case, if I were to set this derivative statement equal to negative 3 and solve back for x, okay, I wouldn't get positive 2 anymore. Okay, so negative 3 cannot be a correct choice. It's only positive 3. You end up with a positive and a negative when you specifically have to square root both sides, not when the radical is already in there. So D is your only choice. Okay. All right, well, that's summing up the multiple choice questions. And now I'm going to move on in a different video. There'll probably be 2 or 3 videos to go through all of the free response questions that people asked for. Those hopefully will be showing up in the near future. All right. See everybody later.